All right, in this video, we are going to talk about solving a logarithmic equation. Here we have log base 2 of x plus 4 equals 3 minus log base 2 of x plus 2. All right, so the first step in solving one of these logarithmic equations like this is to make sure that all of the logs are on one side of the equation. So I'm going to add the log base 2 of x plus 2 to both sides. Okay, so that means over on the right hand side we will wind up with log base 2 of x plus 4 plus log base 2 of x plus 2. And then on the right hand side we'll just have a 3. Okay. All right, so that's step number one. Add or subtract, right, logs to both sides. Make sure that you get all of the logs on one side and then the non-logs on the other side. The reason for that, right, is because in order to solve this equation, what we are going to use, right, is the conversion between the logarithmic form y equals log base b of x, right, and the exponential form, which is b to the y equals x. So basically what we're trying to do is to rewrite our equation, right, so it looks more like this logarithmic form here. And then once we get it in that form, then transform it over to the exponential form. That'll get rid of the logs. So we can solve for whatever it is that we want to solve for. All right, so the first step is getting all the logs on one side. The next issue is that I want a single log on one side over here, and you can see I don't have that. I have two logs being added to each other. So in that case, what we want to do is use the three properties of logs, especially in this case, the product rule for logs, right, which says that the log base b of x times y is log base b of x plus the log base b of y. Okay. All right, and so you can see that the left-hand side of this equation that we have is exactly of this form right here. Log base b of something plus log base b of something else. And what we can do is rewrite it so it looks more like this side over here, which is log base b, and then on the inside of the log I have the product, right, of those two, or multiplication, right, of the two arguments of the log. So that is exactly what I'm going to do. All right, so using that property, this side would be log base 2 of x plus 4 times x plus 2. Okay. All right. And so now my equation does look like this form right here, right? Which is good because then I can just turn around and rewrite it in this exponential form here. So normally when I do that, I start with the base, log base b, right? So this is log base 2. The base of the logarithm in the logarithmic form will be the base for the exponential form in this exponential form down here. All right, so it's going to be 2. And then next I look at the exponent, right? The exponent in the exponential form is y, and that is what is on the opposite side of the equal sign of the log in the logarithmic form, right? And so in that case, in our case, it's 3. So we have 2 to the third power. And then what is inside the log in the logarithmic form is on the opposite side of the exponential function in the exponential form. So over here we have x plus 4 times x plus 2. All right, and so you can see what is accomplished by doing that is all of the logs are gone, okay? And so now we just solve this equation like we have been solving all of the other equations in our class. All right, so first thing is we're going to simplify each side of this equation as much as possible and then see what we've got left when we do that. So 2 to the third power is 8. This is two binomials, so they need to be multiplied out. So x times x is x squared. X times 2 is 2x. 4 times x is 4x. And 4 times 2 is 8. All right, the left-hand side is about as simple as we can get it. The right-hand side, we have these two like terms which can be combined. 2x plus 4x is 6x. Okay. All right, and so now each side is as simple as we can get it. Now then we need to take a look at this equation and decide what type it is and what we're going to do next. Well, when we look at this equation, we can see that it looks like a quadratic equation, right? I have x squared plus some number times x plus some constant number. And over here, I just have a constant number. So this definitely looks like a quadratic equation. And so what I'm going to do is to get it into the standard form, right? Get 0 on one side, everything else on the other side, and then try to factor that equation. And if that doesn't work, if I can't factor it, then I'm going to use the quadratic formula. All right, so getting everything on one side and 0 on the other side, the easiest way to do that is to just subtract 8, right, from both sides. And I am going to wind up with 0 equals x squared plus 6x when I do that. All right, and so it is in the standard form, and so I'm going to factor it. This one's really easy to factor, right? Because the first step in factoring is always to remove the greatest common factor, which is x. And then when I factor out that x, I have the product, right, of these two. And so that's fully factored. So I have 0 on one side, and then these two being multiplied to each other. So if I multiply two things and I get 0, that means one or the other of those two things, or possibly both, is equal to 0. So that means either this x is 0 or this x plus 6 is equal to 0. All right. This and then these are two linear equations, right? This one's already solved. I do need to solve the second one by subtracting 6 from both sides. So I get two possible solutions, x equals 0 and x equals 6. Okay. Okay. So what I need to do now, right, is to check those two solutions. At the very least, right, you need to make sure that when you plug them into the original, right, you get non-negative or positive numbers, right, inside the parentheses. And if you don't, then it automatically can't be a solution, right? So let's go through with the check, and you'll see that, right, one of these solutions is not going to work. Even though we did everything perfectly, right, in this, then that is not enough, right, with these problems. So I'm going to erase part of this here so we can do the check. All right, so the first one we're going to check is the minus 6 or negative 6, right? So when I plug this in, right, I'm going to get log base 2 of negative 6 plus 4. And then I'm really not going to even bother to go any further because straight away something bad happens, right? I have log base 2 of negative 2, right, on this side, okay? and that is an issue, right? This fact that I have a negative number, wind up with a negative number inside the log, means that that -6, right, is not going to be a solution, right? So that solution is going to get thrown out. Now, don't jump to conclusions, right, and think that just because you get a negative number, then that can't possibly be a solution. Some people go too far, right, and they immediately throw out any negative numbers. That's not the case. A negative number can be the solution of a logarithmic equation. It just depends on what is inside the logs, right? So negative in and of itself, right, as a solution is not bad straight away. It's if you plug in that negative number into the inside of these logs and you get a 0 or a negative number, then it has to be thrown out. That can happen just as easily with a positive number or 0 as it can with a negative number. So make sure, right, that you are checking these solutions. So we have to throw that out. Next up, we are going to check the 0 and plug it in and see what we get. So doing that, I'm going to take the 0 and plug it back into the original. So it's log base 2 of 0 plus 4 equals 3 minus log base 2 of 0 plus 2. Okay, and I'm going to do that. So when I start simplifying that, I get log base 2 of 4 equals 3 minus log base 2 of 2. And so far, so good. At the very least, right, you should just check, is the inside positive? If so, right, here and here, so then this is going to be a good solution at the very least, assuming, right, that is assuming that you have done everything perfectly, right? If you made a mistake somewhere, well, then that check is not going to check that at all, okay? You have to go and do the full thing. So now the issue here is that your calculator does not have a log base 2, right, key. Although here you don't really need the log base 2 key. This is a very easy one, right? This is the power you would put on a 2 to get 4, right, which is 2. Okay, so this one is easy to evaluate without a calculator if you understand logs. Right, and then log base 2 of 2, right, well, that's the power you would put on a 2 to get a 2, right, and that would be a 1. So you can see that works. And so checking it all the way through will show if you've, or potentially show, right, if you've made a mistake somewhere else. At the very least, you need to check the insides are positive. So this x equals 0 is a solution, right, to this equation, and it's the only solution, right, to this equation. If you have trouble checking, right, or doing these log base 2 without a calculator, then since your calculator doesn't have a log base 2 key, you would have to use the change of base formula, right, to do that. So log base 2 of 4 is the same as ln4 over ln2, right? So if you punch that into your calculator, if you did ln4 divided by ln2, you're going to get 2 over here. And if you do this side, 3 minus, and then do ln2 using the change of base formula divided by the ln of the base. you get 2. So you can use your calculator, although these, you know, on these you probably really shouldn't be using it, because these are, if you're having trouble with that, it means that you probably could understand what logs are a little bit better, right? But with some other equations, like if this was log base 2 of 5, well, you know, that would be, you know, difficult for anybody pretty much to figure out if that were equal to this other side over here. All right, so that's it on this example.